Hello and welcome to the video series on runtime analysis of AUTOSAR embedded projects. My name is Florian Sommer and I'm responsible for the business development for embedded software here at Vector Informatik in Stuttgart. In this video, I am going to explain a little bit more about the class sampling for the different classes of real-time analysis that I explained in the first video of this series. And we're going to see what sampling is, how it can be used, and what are the ups and downs of this kind of technique. So let's go ahead and start with the general understanding of sampling. So a quite common approach to do sampling is to do pin toggling with the activation and the termination of a task. So many projects use this, for example, with the idle task in order to find out how high the CPU load in the system is. So simply whenever the idle task is getting activated and when it's getting terminated, you switch on and off one of the pins and you measure this output via the oscilloscope. Of course, you can not only do that for the idle task, you can also do that for a certain task, as it is shown here in this example. So we can see a task 2 millisecond, and you can see every time when this task is getting activated, it is here a high signal, and every time it's getting terminated, we're back to low. And by that, you can very easily see what's the total runtime of this task and also what's the overall CPU utilization a certain task is taking. So let's have a look at the benefits. One benefit is quite obviously it is highly available. So you don't need a lot of equipment other than an oscilloscope, which you might already have. And it can be very easy done by simply inserting this pin toggle into the code. So it's very easy to set up and very easy to use. Of course, with this easiness, there also comes a downside. So the effort that you have in order to instrument the tasks and also in order to record these state changes as shown here with the oscilloscope is getting higher the more tasks you want to analyze. So of course, if you do it only for one task, it's fairly easy. But since you have hundreds of tasks in a complex system, it can be quite a high effort to instrument all of them and also to measure them. Then the next downside of this approach is you don't get the details. So you can see now that your task is getting activated and you can see when your task is getting preempted again, but you're not able to see what's happening in between these 2 points. So you will not be able to see if your task is getting preempted all the time and it actually had a very, very short runtime, but was spending most of the time in preemption. Or you will also not be able to see how long was the time from the activation of the task until it actually got to run on the core. And in the end, of course, you will somehow need to remove the code that you instrumented. So you need to do that manually, and you, of course, need to remember to delete it. So much about this class of timing analysis. In the next videos, we will have a look at the statistical approach. At the end of this video, I want to offer you some possibilities to stay in touch and find out more about timing analysis. For that, I'm inviting you to join the LinkedIn group Runtime Analysis in AUTOSAR projects. In this group, you will meet other people working in this field, sharing their experiences and solutions for this topic. And you will, of course, also be able to engage in discussions and ask your questions there. Just search for the group directly on LinkedIn, or if you want to have it easier, I put a QR code here in the video so you can simply scan the QR code and you will be redirected to this group. Would be happy to have you in the group. If you have questions to me directly, or if you want to connect with me, I'm inviting you to scan the QR code here on the right. You can also see the link to my profile here on LinkedIn. I would be very happy to connect with you and answer any questions you have. Thank you very much for watching this video. I'm looking forward to stay in touch with you.